All right, gentlemen, I'll be right with you. I'm just taking attendance to let students in. I have to notify some people, hey, um, you know, I can't see your name, so I can't let you in. So yeah, if your student name isn't showing, you definitely want to go ahead and update that. Update your Zoom profile. So I was able to switch um, and log. I'm able to get into my Morehouse Zoom so that we get the full, so we don't get cut off at 40 minutes, and we get a few other features, but I'm trying to keep it as simple as possible. I'm just trying to get everybody in before we officially get the party started. Nelson. These are interesting names, and I'm going out of my way to not say names because I am live streaming this to my YouTube. Shameless plug. My YouTube channel is Beautiful Mind Pfeiffer. I use it to basically connect with students remotely. So I have like full lectures. I'm redoing these lectures for this course. So I'm just going to do a fresh set. I did the one. Let me just finish getting everybody in before I dive into everything. I hope everyone is doing well. I'm going to go ahead and mute the audio for right now just so I can focus. Williams. But I am monitoring the chat, so like if you have questions or feel free to either raise your hand or type in the chat with your question, and I'll periodically pause to kind of check these things. Man, we got a full house, like for real, for real. There's one user I'm like hesitant for letting them in because they're just not showing their student name. So if you have also it is a good idea to have the contact of at least 3 of your classmates in all your classes. So if you have a brother that you know that's waiting in the waiting room that's not showing their full name, tell them, hey, you need to log out, show your name, and update it. Because I'm inclined to not let them in, because otherwise it'd just be chaos. Just trying to keep the chaos to a minimum. I mean, we always have a workaround for things. Here's another one, and I'm not sure who this is. Okay, I have a sense. I'll just try to say it again. Okay. All right, so I'm gonna let this person in for now. All right, so there's someone I just let in. Their student name wasn't showing. I'm not sure who you are. I just let you in for now, just so that you're not missing out. You want to definitely update your username to show your student name, so that you can get attendance credit. Right now, whoever Zoom user is, I didn't give you attendance credit, and you don't want that stuff piling up like that. Okay, so if you want credit, you have to like either direct message me and definitely like update your username so that you can get attendance credit. You don't want to be here and not get credit. Okay, let me make sure. I think you guys can hear me okay. Let me check the chat real quick. Yeah. So there was a question. So for the lecture one, like I said earlier, I'm redoing these presentations. So I've already done section 1.1. I did that earlier with my students. I made a fresh video presentation available. I do expect you to watch these on your own and then come to class with questions. So what I'm going to do today is kind of go ahead with, yeah, who was this? Okay, I got you. All right, cool. No worries. So I got you, Mr. Zoom user. So I was able to update it. You got attendance credit. Yeah, but just definitely update your profile. That just makes things easier for me to kind of keep it moving. Also, so class starts at 2. You guys are great. You're here. No worries. About 2:15, I may or may not let you in past 2:15. Because like I think the first wave that I take attendance is full credit, and then if you show up after I finish that, but before 15 minutes, that's considered late. And then after 15 minutes, I may or may not let you in the class, but I definitely won't give you attendance credit for that. So yeah, with section 1.1 video presentation, like I said, I redid that one from earlier, so I'm making a new playlist. If you go to my YouTube channel, you'll see it there. I might link it to the homework, something like that. But it's there. I made a fresh one so you can kind of see those videos. I'm going to expect you to watch that on your own. Also, we are doing an asynchronous design. What I mean by that is all I really need you to do is on each session, just check in and get your attendance credit. You get attendance credit by getting into my Zoom. I usually do important announcements like the first few minutes of class. And you're not obligated to stay in my eyes. Like all you have to do is get your attendance credit and make sure your stuff is submitted. I'm making video presentations available on my YouTube. All the homework and quizzes and exams, most of the exams will be on Pearson. Right now on Pearson, all of your homework for the semester is available. Probably by the end of the week, I'm going to go ahead and make all of your quizzes for the semester available with their corresponding due dates. And then the exams, those are going to be available closer to those times. We're going to have like exam 1 is in week 4, exam 2 is in week 8, exam 3 is in week 12, and then shortly thereafter we'll be moving into the final. So again, hopefully you guys can hear me okay. I think you can. I think I was muted with my earlier class, and then they notified me, and I was able to update it. And I think my audio is working good for YouTube. So with that being said, without further ado, I'm just going to kind of keep moving forward. So I know we haven't officially gone through 1.1 together. I did do a recording. I expect you to watch that recording, take notes if you're in class. And so what I'm going to go ahead and do now is go ahead and do section 1.2. And most of the concepts are not that difficult. I feel like you can handle it. I might get a little bit ahead in the presentations just to kind of stay on track. Let me see who we got. It's either A or P. Let's go to the P's. Yes, this one. Okay, cool beans. Okay, so again, yeah, for right now, I have my audio muted, so just so I can focus. And either if you have a question or need help with anything, raise your hand or use the chat. Let me see. We got another one. Let's go like this. Come on. Mr. And I think I got him. Cool beans. Okay. So like I said, I'm going to go ahead and move into section 1.2. Let me see if this is lagging today. Let me check one other thing. Yeah, it's okay. I think it'll work. Okay. It's a little bit of a lag, but I think I can work with it. Okay. So, like I said, I redid section 1.1, graphs of equations. So that's on the playlist. If you need help finding that, it's on my YouTube channel. If you need help finding that, just let me know. Right now, we're going to go ahead and move into section 1.2 lines. Okay, so what you see here are a list of objectives that we're going to kind of touch on in this section. We want to find the slope of a line. We want to write the point-slope form of the equation of a line. We'd like to write the slope-intercept form of the equation of a line. We want to recognize the equations of horizontal and vertical lines, recognize the general form of equation of a line, and find the equations of parallel and perpendicular lines, okay? So when you go back and watch the recording, the updated recording for section 1.1, you'll hear me mention things like about formula sheets. So hopefully you're taking notes, right? You have a notebook where you're taking notes as if you're in class, you're writing down things that are pertinent. But in your notebook, you want to have either in the very front or the very back, have a formula sheet section, a section where every time you come across a formula, you update that sheet with the new formula. So let me see. I think we had like 3 formulas in today's presentation, and then in this one, let me see. So we're talking about slope, right? That's a little bit better. We're talking about slope. So we're definitely going to have some formulas that pop up here. Let's just kind of talk about it, and I'll kind of point out what formulas you need to update your formula sheet with. Okay, so let's start off with some definitions. Since the graphs of first degree equations in 2 variables, let me see, all right, I'm getting a little bit more smooth with attendance and things of that nature. So since the graphs of first degree equations in 2 variables are straight lines, these equations are called linear equations, right? We measure the steepness of a line by a number called the slope, right? This is intuitive. You know what this stuff means. So the rise is the change in y-coordinates between the points, and the run is the corresponding change in the x-coordinates, right? So slope, like if you think about slope in your everyday life, where do you talk about things that have steepness? Like if you talk about how steep something is, where have you seen slope? So some examples of where you might see slope in your everyday life would be like a hill. Like if you're walking up a hill or riding a bike or driving a car up a hill or down an incline like onto the highway or something like that, that's going to have a certain slope to it. We're surrounded by like lines and straight edges and slopes and things of this nature all around us. So So that's what this topic is about, just basically slopes. So we're gonna talk about slope as rise over run. Rise is going to be the change in y coordinates between points, and the run is going to be the change in x coordinates between points, right? So let's keep going. So the slope of a non-vertical line that passes through the points P and Q is denoted by little m as defined by this. So this is one of the formulas that you would want to add to your formula sheet. Again, this is section 1.2. I went on and redid section 1.1 earlier today. So you want to go back and watch that video, take notes as if you're in class. I think we had at least 3 formulas in that session that you definitely want to add to your list. I think he was already in here. Okay. So this is another formula that you want to add to your list. This is called the slope formula. And again, slope is basically your change in y over change in x, which is the rise over the run. Change in y over the change in x. Okay. The slope of a vertical line is undefined. So in this example, we're asked to sketch the graph of the line that passes through this point P and Q, and then find and interpret the slope. So for the sake of simplicity, I just went on and used the information that was already given for this one. So the graph of the line, so basically if we plot the points, we got P and Q. I see the chat, I'll address it momentarily. We have the points P and Q. So P is the point 1, -1. So to plot P, if we start at the origin, we go right 1 and down 1, and there's the point P. The point Q is the point 3, 3. So if we go right 3 and up 3, then that's going to be the point Q. So then if we want the line between those 2 points, we just basically use a straight edge and connect the 2 points using a straight edge. So then the slope is going to be the rise over the run, or the change in y over the change in x, right? So, okay, so I'm going to actually take some notes here. So again, one of my suggestions is every time we use a formula, write it down. So the slope between 2 points is y2 minus y1 over x2 minus x1, right? So if we want the slope between these 2 points, we're going to use this formula, the slope formula. Also, my recommendation is every time we have a set of ordered pairs, I just automatically label it. I'll go x1, y1, x2, y2. Now, I know I talk a little fast and it's a lot of information, but this is why, for the following reasons, is why I prefer teaching remotely and recording my sessions. That allows me to just kind of flow. I can talk at my natural rhythm. It's okay if you just like step away from this stuff for however long you feel like you need to. But because it's recorded, you can come back, pause it, slow it down. You can rewind it. You can change it to match your pace and rhythm. You can pause it because I know I kind of, it's a lot of information jam-packed. And in the past, it was intense to do that in person. With this, I feel like you just have to take advantage of the time factor, right? Because it's recorded, you got to take advantage of the time factor. It takes a little bit longer, but with determination and diligence, anybody can get this. It just takes a little bit of effort. Also, I would recommend go ahead and seek out the tutors. If you're in College Algebra 1, you definitely want to take advantage of the tutors. You've already paid for them. They're sitting there waiting to help you guys with this. So I know my energy can be a little intense. That's why another reason why I prefer remote, because I know my energy can just be intense. But don't get it twisted. I do see the value in being in person. But for the sake of my sanity, I prefer to be remote. It's just I have what I need when I need it versus waking up early, driving, battling traffic, getting to some location, dealing with the school's technology versus my technology. My technology is a lot more reliable. So I'd rather deal with my stuff than a standard stuff. I don't really fit inside of norms. I have to do my own thing. And if I'm not given the freedom to do my own thing, it's going to be trouble. I already know it. Like I have to be free. I have to. So, that's for a topic for another discussion. So we went on and labeled the points x1, y1, x2, y2 for the given order pairs. We're going to use a slope formula. So let's just go ahead and plug in what we have, right? So what's our y2? Our y2 is 3. Our y1 is -1. Notice my use of parentheses. Our x2 is 3. Our x1 is 1, right? Double negative becomes positive. So 3 plus 1 is 4. 3 minus 1 is 2. 4 divided by 2 is 2. So then our claim is that the slope is 2, right? Hopefully that wasn't too fast. Okay. So we got a slope of 2, and it's already there, but I just kind of wanted to walk you through it. Oh, also another thing. So I will make links available for all of these like handwritten notes that you see me writing. I'm going to make them available for you where you can get a copy of all the stuff that you see me writing. I'm just kind of waiting because there's still an issue with my Blackboard. So once that's resolved, then I'll just sit down and update it with as many things as I can, and that needs to be updated. Okay, the time. Okay, so it's been 15 minutes past the start of class. So I'm going to go ahead, and those people that are not here, I am going to go ahead and mark them as absent. But I mean, we had a decent turnout. Wait a minute, I think that student's here because I know I saw that name. Let me check I'll go to users. I am looking for. I don't see him. Okay. Let me check this really quickly, and then we can address some of the concerns. Okay. Oh, definitions. I don't know how we got there. Okay, this is where we left off, and I think they got the same result that we got. Okay. I'm going to leave it here. I'm going to pause for a moment and check. I'm going to check the chat. Let me see what it's looking like. So my YouTube is Beautiful Mind Pfeiffer. There's a link. It's all over the place. My link is on our Blackboard. Beautiful Mind Pfeiffer. Yeah, or you can type in Beautiful Mind Algebra. That'll get you there. I think that was it. I think I saw a hand. Let me unmute myself. And did somebody? I guess the hand is. Somebody had a question. Yeah. Mm-hmm. So if you did the homework on Pearson, with our homework assignments, we get unlimited attempts. If the due date has already passed, you can you can still earn more credit. You can get up to 90% past the due date on anything. So we get unlimited attempts at all assignments. If you got an 85, you should be able to push it to at least a 90 if you wanted to, because it's only a 10% late penalty for only questions submitted past the due date. So the way Pearson is set up is designed to take your highest score. I'm just gonna. Okay, go ahead. Say that one more time. So go ahead. Let me see. Just kind of remind me towards the end of class. Let me kind of get to the end of class. Like it'll be about like 5 minutes left on the clock, and then just remind me then, and we can look at it. In the meantime, go ahead, go find that question, like pull it up on your end, and click on the Ask My Instructor and say, hey, I think I got this question right. Can you look at this for me? And I'll look at it. So, and it'll come straight to my email. So just remind me at the end of class when I let everybody go. Okay. Okay, so with attendance, the main thing with attendance for this like first couple of weeks, don't stress too much about it. Like if you missed last week, don't worry about it. As long as you're, yeah, just remind me towards the end of class. Yeah, because I don't want that to pile up. So I'll give you credit for it for now. Yeah, it's fine. Like up to about 15 minutes. Like I think somebody just came in after the 15-minute mark, and I don't think I gave them the credit. But if you get in here before 15 minutes, like if we start at 2, if you get in here before 2:15, I generally give you credit. But after 2:15, then I start to like I'll let you win, but I might not get you credit. Right? But I'll be kind of lax for like yesterday and today because it's like the first week we're getting used to everything. Go ahead, gentlemen. There's another one. Was that it? I haven't made the quizzes yet. Hmm. Yeah, yeah. No, that yeah, you definitely got to pay attention to that. And again, that's why I do unlimited attempts. Because sometimes you guys think it's right and it's actually wrong. But if you want to dispute it, just click on the Ask My Instructor and remind me at the end of class today. Okay, like it'll be about 5 minutes left on the clock, and just stop me then. I mean, because I'm gonna let you guys out, and we can address that then. If you want to join Pearson, you join Pearson through Blackboard. Yeah. Okay. So I'm gonna mute the audio for right now, just to kind of get back on track. If you have questions, either type it in the chat or write it down, and we'll open the floor back up a little bit later for more questions. Okay, let's keep it moving. These are good questions, though. These are good. So some main facts about slopes of lines. Scanning graphs from left to right, lines with positive slope are gonna rise, and lines with negative slope are gonna fall. So when we trace a graph from left to right, a positive slope is gonna go up, a negative slope is gonna go down. The greater the absolute value of the slope, the more steep the line is. The slope of a vertical line is undefined, and the slope of horizontal lines is 0. Or the slope of a horizontal line is 0. Okay, let's keep it moving. So if a line has a slope m and passes through this point, then the point slope form of the equation of the line is this. So there are 3 equations whenever I'm working with lines that I like to use. We've already seen one of them, which is called the slope formula. The slope formula again was y2 minus y1 over x2 minus x1. This is the second formula that I like to use whenever I'm working with lines. This is called the point slope form of the equation of a line. And it's given by y minus y1 equals m times x minus x1, where x1 and y1 are the coordinates of the given point, and m is the slope. I use this formula whenever, we like to use this formula whenever we're given a point and a slope, right? Okay. So this is another formula to add to your formula sheet. Are you slowing down on me? Okay, let me reboot you. Right here. Okay, and we are working here. And let's get back to where we left off. We left off right about here. Okay. All right. So I think we talked about that. So here we're asked to find a point slope form of the equation of the line passing through this point with this given slope, then solve for y. Okay. So again, whenever we use a formula, it's a good idea to just write that formula down. So it says find the point slope form, so it's a good idea to use the point slope formula. Point slope formula, I'm gonna go ahead and label it point slope. It's given by y minus y1 equals m times x minus x1, right? Okay. Hopefully that wasn't too loud. Let's see. So we're given a set of ordered pairs. We're only given 1 point, so we can go ahead and label this as x1, y1, and we've identified our slope already, right? So then if we plug these in, we're going to have y minus y1 is -2. Notice my use of parentheses for that negative. The slope is 3. X minus x1 is 1, right? Okay, and let me do like this so it's a little bit more clear where I'm getting these numbers from. The 2 and the 1. Style. I'm gonna make them purple. Hopefully that helps. Okay. So, and then if we want the point slope form, we're gonna get y plus 2 equals 3 times x minus 1. And then it asks us to solve for y, so I'm gonna highlight this as one of our results. And then if we take that and solve for y, I would like to distribute this 3, and I'm gonna move the 2 to the other side through subtraction. Okay, let me go ahead and distribute first. So then this will give us y plus 2 equals 3x minus 3, right? If we want to isolate the y, we're trying to get the y by itself, we're going to move the 2 to the right side of the equal sign through subtraction, basically using opposites, the inverse operation. So the inverse operation of addition is subtraction. A number plus its opposite, these go to 0. The y comes down, the equal sign comes down, the 3x comes down. -3 minus 2 is -5. So when we solve for y, we finish with this result. Okay. I see some activity in the chat. Let me check my result. Let me see. Find the point slope form of the equation of the line passes through this point with that slope. So the slope is 3. We can see that the slope is 3. And then if we plug, when x is 1, y should be -2, right? I'm just going to go with that for now. You can check it. So we have this. I think they finished with the same result as us. Okay, let me go back and check the chat. I saw some activity there. Is it like this? Nope. There it is. Yeah, so the access code for Pearson, you have to purchase access, right? I think one of my students was telling me it costs about $105. But the thing about it is, like, once you purchase access, we use the same book for College Algebra 1, College Algebra 2, and pre-calculus, right? So you should be able to, like, if any of your other teachers use Pearson and it's the exact same book, you don't have to purchase access again. So you should be able to use it for at least 3 of our classes, right? At the current moment, that's the idea, okay? But yeah, you do have to purchase access, but that should be good for you for like at least 3 classes. So let me see the time. Cool, we're looking good. I'm gonna keep it moving. So in this example, we're asked to find the point slope form of the equation of the line passing through these two points and then solve, right? Okay, so again, one of my favorite things to do whenever I'm given a set of ordered pairs, I just like to automatically go ahead and label it x1, y1, x2, y2. So that's one thing you don't have to think about. I'm going to encourage you to think in my class. I know a lot of people don't like to think, so, you know, in this drastically fake society, people are afraid of the truth, you know, because the truth hurts, you know, and so that's why we have a lot of censorship and stuff like that. But I don't shy away from it. Most people do, you know, and it's okay. It's nothing wrong with it. It's just a different style. And right now, you know, if you know how to will and deal and lie, cheat, and skill, unfortunately, it does seem like it gets you ahead, but the drawback is that kind of activity is very limited, and it comes with its own self-destruct button. So where you might get ahead initially, in the long run, it doesn't stand a barrage. It doesn't stand the test of time. The energy of lying, cheating, stealing, killing, all that kind of stuff, it doesn't last. It's only good for like short term, but long term, it messes you up. Anyway, so all right, so we're going to find the point slope form of the equation of the line. So if we're going to use the point slope, I'm actually not a fan of the point slope. I'd rather use a different one. But for right now, just for the sake of, you know, practicing our formulas, I'm going to go ahead and use the point slope. So point slope is y minus y1 equals m times x minus x1, right? Every time we use a formula, write it down. Okay, we've labeled x1, y1 already, so we also might need the slope. So this is the point slope formula, but we also need the slope formula, right? So the slope formula, the slope is going to be y2, that's not a 2, y sub 2 minus y sub 1, or y2 minus y1 over x2 minus x1, right? So my space is a little limited, but that's okay. So then our slope is going to be y2, which is 7, minus y1, which is 1, over x2, which is 3, minus x1, which is negative 2. Notice my use of parentheses. I put a parentheses around my negative number, so that way we can distinguish between the minus and the negative, right? So then if we go ahead and solve for the slope, 7 minus 1 is 6. 3 minus negative 2, double negative becomes positive. So I'm gonna notate that here as such. 3 plus 2 becomes 5. All right, so now we have our slope. We have our slope, we have a point, so we can find the point slope form, okay? Let me see. So then we're gonna say y minus, now our y1 is 1, equals the slope times x minus x1, which is negative 2. Okay. So the point slope, we can go with like y minus 1 equals 6 over 5 times x plus 2, right? So then it asks us to solve for y. I'm kind of running out of space. I mean, I can create space, but I'm just trying to get it to fit here. First thing I would personally like to do, I'm going to get rid of that fraction by multiplying the left and the right by the LCD. So long story short, I'm going to multiply the entire left side by 5, and I'm going to multiply the entire right side by 5 as well, right? But there's a little bit of a catch there. Now on the left, if I multiply by 5, I need to distribute. Okay, so then I get 5y minus 5. On the right, what actually happens because of the associative property of multiplication, when I say 5 times 6 over 5, they actually just cancel. So this 5 is actually canceled by this one. So on the right, I'm only going to be distributing that 6. Okay. So if I distribute the 6 on the right, I get 6x plus 12, right? So if I want to solve for y, I'm going to just kind of do this in one go. Add 5. Well, let me just do it just so I'm not. So I'm going to add 5 to both sides. Because this will get faster for you. On the left, we have 5y. On the right, we're going to have 6x plus 17. And if we want to solve for y, I'm going to divide both sides by 5. So then y equals 6 over 5x plus 17 over 5. Okay. So this was the final equation that we got. And we can check by verifying the original notions. And then I'm just going to highlight this. This over here was our point slope form. Okay. So let's compare this to the typed up notes. I think we got the same slope, so that looks good. They plugged in, let me see, 3 and 7. Now notice, they chose the other point. We chose the point -2, 1. They chose the point 3, 7. But again, the point slope formula, you just need the slope and any point on the line. So they chose a different point, but notice they finished in the same place that we did. So there's, long story short, there's more than one way, there's more than one correct way to go about these. You don't really need to know all the correct ways. You just got to find at least one of the correct ways that works for you. Okay, it's a lot like life. You know, we got 7 billion people plus on this planet. You can't convince me that there's only one correct way to go about this life. 7 billion people, there's only one correct way. I beg to differ. Let me see the time. Time is looking good. Okay, let's keep it going. So I think we got the same thing, 6 over 5. Yeah, so we're going to go with it. Okay. And again, I'll make a copy of all the things, all the notes that you see me writing. I'm going to make it available for you. Okay, let me see. Oh, we got a ways to go. So more than likely, I will run out of time. So what I'm going to do, I probably will release you guys, but I'm going to keep recording, keep streaming, just so I can get this whole section in one clean take. You're welcome to go back and watch it at your convenience. Take notes as if you're in class, you know, things of that nature. But for right now, we're just going to kind of keep pressing forward. Let me check the chat really quickly. I think the chat was clear, so I'm not going to worry about it. Next, we're asked to find the point slope form of the equation of the line with this slope and with a slope of m and a y-intercept of b, and then solve for y. Okay. So point slope, we usually do y minus y1 equals m times x minus x1. Okay. So it says the slope, we're given that the slope is m, and I'm just going to say the y here. Let's clean it up a little bit. So we're given that the slope is m and the y-intercept is b in this case, right? So if the y-intercept is b, that ordered pair is going to be the point 0, b. Okay, so let's plug these ideas into our formula and see what happens. So we're going to say y minus, now our y1 is going to be b, our slope is m, x minus x1 is 0, and that being at 0 came from right here. This was x1, y1, right? Corresponding to this b and this 0. Style like that. Okay. Okay, let's keep going. So if we distribute this m, we're going to get y minus b equals mx minus 0. And then add b to both sides. And this should look familiar. So then we'll finish with y equals mx plus b, right? So this is actually the third formula. Whenever I'm working with lines, this is actually the third formula I like to have ready to go. Okay. So you see they got the same thing that we did, y equals mx plus b. And so this is the slope-intercept form of the equation of the line with a given slope and a y-intercept b. All right. This is my favorite. This is the one I wanted to use a moment ago, but I was like, well, I know we hadn't talked about it yet. So I was like, well, let me just wait because I knew it was coming. So I was like, let me just wait and not use it just yet. I generally like to use this one a lot, like over the point slope form, but let's keep going. So we asked the graph a line with this equation, right? Let me see something. So I'm going to do, no, just for the sake of time, I'm going to use the graph that's already there. I could create one. Yeah, I don't think it takes that much. Let me do like this. Kind of like this. It should be able to go away and come back. Paper, graph paper. Looks good. Okay. Come on. Oh, you lagging on me now? You lagging on me, bro? Come on. Come on. All right, let's try it out. Here. Yep. Okay. So we want to graph this. I'm just going to make a quick Cartesian plane. So I'm going to go like this. That looks good. Can I just like copy up? Oh, well, that works. Let's paste. That looks good. I just want to paste another one. Can I like just, that's fine for now. Something like this. Okay. So just making a quick Cartesian plane. This is our x-axis here. This is our y-axis here. Let me label some tick marks. So we got 1, 2, 3, 4, 5, 6, 7. That's good. Let me copy and paste. I probably should have just gone my first mind and used. Try one more time. Use the one that was already there. Ugh. Copy, paste. Looks good. Okay. Okay, that's fine. Paste. Okay, that's about as quick as I can do it. Looks decent. Okay, delete. Okay, and then let me just label this really quickly. So like this is the origin. This is 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. These are negatives. 1, 2, 3, 4, 5, and these are negatives. Okay. So now we're asked to graph this. Let me make a copy of this slide so that if I, just in case, let me copy and paste. Hopefully I can use it going forward for a blank. Okay. All right, so graph this line. We have y equals 2/3 x plus 2, right? So if because it's a line, let me see the time. I don't want to keep it for, I want to keep it for about, right at about 5 more minutes. So in this form, we have this is already in the form of y equals mx plus b, right? So our b is 2, so that means on the y-axis we start at 2. That's our y-intercept is 2. And then they give us a slope of 2/3. So we get a second point by going up 2 and right by 3. Let me do like this. Come on. Paper. I'm going to change it to this. Okay. So we're starting at the first point. The slope tells us how to get a second point on our line. If we go up 2 and right by 3, 1, 2, 3 right there. Then we just want to connect that with a straight edge. I'm going to do another point. 1, 2, 1, 2, 3. And I'm going to go the other direction as well. 1, 2, 1, 2, 3. 1, 2, 1, 2, 3. I think that's about there. Okay. Do one more. 1, 2, 1, 2, 3. About there. Okay. So then if I connect these with a straight edge, we get this. Okay. I'm just being a little bit OCD, just bear with me. Okay, notice I put arrows on either side. It's a straight edge. Okay, that's how we graph a line. So the y-intercept tells us where on the y-axis to start, okay, and then the slope tells us how to get a second point on a graph. Then we connect those 2 points with the straight edge. Again, all the stuff you see me writing, I'm going to make it available. So just write what you feel like is pertinent. Okay. I think the chat looks good. I kind of been watching. I hadn't seen any questions pop up in the chat. So I'm going to keep moving. Graphs of horizontal and vertical lines. So for any constant k, the graph of the equation y equals k is a horizontal line with a slope 0. Okay, so when you graph a constant, it's going to be a horizontal line that has a 0 slope. The graph of the equation x equals k is a vertical line with an undefined slope. So if you have y equals k, that's going to be a horizontal line with slope 0. X equals some constant is going to be a vertical line with an undefined slope. Okay. So here we actually discuss the graph of each equation in the xy plane. So for the first one is y equals 2. So for part A where it says y equals 2, that means that given no matter what x value you choose, the corresponding y is always going to be 2. So for instance, if x was 0, y is 2. If x were 7, y is 2. If x is negative 3, y is 2. And you can see those plotted here. If x were 2, y is 2. If x is 0, y is 2. If x were 7, y is 2. No matter what x value we choose, the corresponding y is always 2. So that's going to be the graph of a horizontal line that has a slope of 0. Right? For the second one, with x is equal to 4, that means that x is always 4. You can work in reverse. No matter what y value you choose, for the second example, the corresponding x is going to be 4. So when y is 0, x is 4. When y is 7, x is 4, so on and so on. No matter what y value you choose, the corresponding x is going to be 4. So when we plot that, we get something like this. When y is 0, x is 4. Y is 2, x is 4. No matter what y value you choose, the corresponding x is 4. So that gives us a vertical line with an undefined slope. Okay, we say that this has an undefined slope. Let me see the time. Let me keep it for like right at about 2 more minutes. I don't have that many more slides, but I do want to honor your time. I don't want to keep you past the time. So what I'll do is let me see the graph. Okay. So I'm going to pause right here and open the floor for questions, or if there's anything like that you feel like we need to discuss. Some updates. I will be adding your quizzes with their due dates. This quiz from week 1, obviously I'll give you an extension. The quizzes will probably be short, like no more than 5 questions. I want to go ahead and make a quiz for the entire semester. And the difference is that the quiz is going to be a lot closer to the way what you can anticipate with the exams, where it won't have like the support, but it should, that's the long and short of that. If there aren't any questions, again, if you do have questions, feel free to either type it in the chat, raise your hand, or unmute yourself. I'm gonna go ahead and bring my audio back. Feel free to unmute yourself and ask your question. Go ahead. Can you hear me? Yeah. Honestly, class time is the best time. You can email me, but when I'm not in class, I just be moving and grooving. So I use email more so for records, just to have it on file. But this is honestly the best time. Yeah, this is the best time. So like if you have a question, like now is good. And if we need to do like If it needs to be like a private setting, I can do like a group or room, so that way it could just be me and you if you need that. Does any does anybody need that? Or you can do a direct message in the chat as well. But if you need a room, I can do that. So wait. So someone said something about 50 for attendance today. So don't stress about those scores for attendance. As long as you're getting attendance credit. I don't. Let me see. Let me check this student because I think that was a student that came in a little bit late. It may have been like a few minutes late, past the 15-minute mark. Let me just check again. Let me check again. And if, it might be 50 because it's factoring in the last class, so you might not have got attendance credits for last time. Um, hang on. Let me go because I'm pretty sure that's what happened with that student. Uh, Yeah, honestly, I mean, it's not. So the attendance isn't factored into your grade. The attendance only becomes an issue if you like rack up a whole bunch of unexcused absences. So for yeah, so it's not part of your grade. It's just for records, and it really only becomes a factor if you get like it's. I think it's either three, but definitely four. Like if I see four more unexcused absences, then I'm like, hey, is everything okay? Then that's when it becomes trouble. But it doesn't go into your grade. Your grade comes pretty much from Pearson. That's where the bulk of it comes from. Yeah. No. Don't worry about that. Like, no, breathe. Just breathe. Go ahead. Mr. Johnson, I'll be with you shortly. Or Mr. Johnson, if you feel like just typing in the chat, that works too. Because I don't think you guys can see my chat. You can do a direct message. Go ahead. Who? I'm not sure who was speaking. Uh, mm, Actually, the homework is loaded. The homework for the entire semester is already loaded on for the on Pearson. Hmm. Yeah, I just haven't made the quizzes yet. So it's just it's a one quiz. No, one quiz a week, like for each section. It's a short quiz, like 5 questions. You get unlimited attempts, and I'll give you, you'll see the deadlines there for those or the due dates. Yeah. Just be prepared to for an oral exam for the midterm for exam two. So I haven't worked out the details for that yet. I'm still kind of like mulling that over. Huh? I'm saying now, like, yeah, just be prepared for an oral exam for exam two. Yeah. Yep. Mm-hmm. Yeah, you can use that. But all of our assignments. Oh, well, yeah, it's fine. Yeah, that should be okay. It's just so what I would do is I would still go set up your Pearson anyway, because they give you an option for getting 14 days of temporary access. So that way you're not getting behind. You can go ahead and get started, and then once your book arrives, use that code, to get full access. Yeah. hmm it's on the page when you're going through Pearson and it prompts you to pay. It's going to be towards the bottom of the payment page. So when it prompts you to pay, it's going to be kind of towards the bottom of that page. You need access to Pearson. So to access Pearson, you go to our Blackboard, you click on the homework, and then when you try to get, you're gonna be prompted to like register for Pearson, and you're gonna be prompted for payment, and it should be like about $105. Um, no, you just need access to Pearson. I redid that one. So I made another one that has the working video earlier today. It's in the playlist. You'll see it. Just go to my channel and you'll see an updated one for the first section. Mm-hmm. You accessing it through Blackboard? Are you accessing it through Blackboard? What what kind of error code? What does it say? When you go, how are you access? There might be something I need to do on my end. It should be there though. I would say reach out to Pearson, like contact the Pearson support. Screenshot your error code, email it to me, and I'll try to get it resolved. But also reach out to Pearson as well because that sounds like something that's out of my control. Because if other students are able to get in through Blackboard, then there's nothing more that I can do. So you'd have to reach out to Pearson, and we'll kind of keep going back and forth until we get it resolved. Mm-hmm. Yeah, you guys are free. I'm gonna actually keep going with this section though. I have another class that'll be joining in a matter of minutes. But yeah. Oh yeah, yeah, it's fine. It's totally okay. Cause I'm still live streaming this, so this is gonna be on my channel. Okay. Yep. All right. Let me go ahead and prep. Yep. You as well. Let me prep for the next class, and I'll take that attendance. Go ahead. Okay. Okay. You go into Blackboard, and I think it's like folder number 4 that says assignments, and that's how you gain access to the course, and then you have to pay for like an access code. It's like $100. You'll see it pop up. Yeah, it's really you just need access. You need an access code to Pearson because the Pearson also comes with a digital book. It's a digital copy of the physical book. So all you really need is the access code because that's how we're doing homework, quizzes, most of the exams. It comes with the e-textbook, explanation for each. The Pearson is the main way that we're doing everything. Mm-hmm. Okay, I know there was one that was requesting private. Are you still there, or did your question get answered? If I don't hear anything, I'm going to kind of keep moving. I think this is the right class. I'm just getting ready for my next class. We're going to hop back over to here, and it should show up here. That looks good, almost. And let me get back to where I left off. And it seems like this thing is dragging, so let me reboot this. Okay. So I'm watching the clock because, I have other students that'll be coming in shortly. I'm just going to kind of keep moving with this topic and go where I left off from. Okay, right here. Okay. So I'll take a few minutes. I'm just going to kind of keep going, and I will have to stop to kind of take attendance for my next class. But I'm going to just go with it for now. Okay, I think this is right. Okay. So I think we spoke on this one already. So the graph of every linear equation, ax plus by plus c equals 0, where a, b, and c are constants and not both a and b are 0, is a line. The equation ax plus by plus c equal to 0 is called the general form of the equation of the line. So if you have your formula sheet, it doesn't hurt to add this one. Let's see, Du Bois. Okay, so I'm going to go ahead and let you guys in. Right now, I'm just trying to wrap up the previous section, and then once I'm done, I'll give you guys updates. So just kind of hang tight as you come in. I'm gonna do my best not to be repetitive because I know. Let me see if I go like this. Oh, I guess they got in, or maybe they left. I'll give him credit because I saw that name. I don't know how he got in. Oh, you must be from the previous class. Okay. All right, I'll let that be. And then we got this student. Okay. So yeah, just hang tight. I'm trying to let you guys in and wrap up this other one. I can't see your full name. Okay, I found him. Okay. All right. So let me try to wrap this up. Let me see the time. I'll come back in like a few minutes. All right. So the graph of every linear equation is going to be a line when we take on this form. Again, this form is called the general form of the equation of a line. I'm not seeing this student. Okay, let me let the student know that I don't see them on my roster. Okay. So there's a Mr. Johnson. I just let you into the class. I don't see you on my roster unless you have a different name that you go by. So I just want you to be aware of that. If you have a name that begins with a P that you go by, I see that in my roster, but I don't know if that's you or not. Okay, so what I'm doing right now, I'm just trying to finish up this presentation, and then I'll come back and do announcements and kind of give you guys an update. So with this example, we're almost done. It's only like a few more slides. So with this example, we're asked to find the slope, y-intercept, and x-intercept of the line with this equation, and then sketch the graph. Okay, let me let this student in. This isn't too bad. Okay. So find the slope. So to kind of recap some of the notions that we've been talking about, and again, I'll give you guys an update on what I'm doing. Let me see. So we have the slope. So let me go ahead and write the slope formula. So again, slope is going to be y2 minus y1 over x2 minus x1. Actually, we're probably going to do a little bit differently here. Yeah, let me scrap this for right now. Okay. So let me start by getting a copy of the original. We have this 3x minus 4y plus 12 equals 0. Okay. Now, the slope. I guess I could do that. So I'm going to bypass the slope first. I'm going to do the y-intercept first, right? So you'd have to go back and watch my presentations, and I'll point you in that direction. But to find the y-intercept, what we do is we set x equal to 0 and solve, right? Okay, so if we set x equal to 0, what we're going to get is 3 times 0 minus 4 times y plus 12 equals 0, right? So this term goes to 0. If we subtract 12, long story short, you get y. Subtract 12 here, let me just show it, because I really want to skip steps, but I was like, well, let me not do that just yet. Okay, so then you get negative 4y equals negative 12. Okay. And then divide both sides by negative 4 and y equals 3, right? So that's the y-intercept. Okay. And then for the x-intercept, that's where the graph crosses the x-axis. For the y-intercept, we set x to 0. So for the x-intercept, we set y to 0. Okay. Let me see. Let me let these students in. And then we got. Okay, so also, guys, it's a good idea to show your full student name. So I'm not like just show your official Morehouse name, so that way it's easier for me to give you attendance. I'm not having to like figure out who's who. Like for instance, this student, I think this is him. Hang on. I think this is him. But again, you don't want your credit going to someone else, right? So you definitely want to like make sure, because this is supposed to be a professional setting, so you want to make sure to have your student name showing on your Zoom, so that way, just for to be professional. Okay. Okay. Maybe I can keep that open. Okay, that's fine. I'll put it over here on the side. That's fine for now. Okay. So for the x-intercept, we set y to 0. And again, I'm almost done with this, and I'll give you an update to what's going on. It's just kind of hard because people are trickling in. But it's okay. That's to be expected. Okay, so we set y to 0. Okay, so then we have this 3x minus 4 times our y, which we set to 0. Okay, plus 12 equals 0. Okay, again, this term, anything times 0 is 0. And I'm going to go ahead and subtract 12 on both sides. Okay, and again, I'll give you guys an update, because what I'm trying to do is wrap up this section 1.2, and then I'll tell you how to find everything. We get this, divide both sides by 3. Okay, and then we get x equals, I think that's a -4. That's the x-intercept, right? So if we want the slope, I kind of need more space. So the y-intercept is 3, right? That can also be rewritten as 0, 3, right, for the y-intercept. Style. The x-intercept is -4, so that can also be written as -4, 0 for the x-intercept. So then if we wanted to find the slope, we can use the slope formula, which is rise over run, change in y over change in x. 0 minus -3. So it's basically going to be -3 over -4, which is just 3 over 4. I didn't write that down because I'm kind of out of space, but that should be the slope. So now all the stuff that we were just talking about here with this example, we should have a typed version of it here. Okay, so the slope is 3 over 4. The y-intercept is 3. So to find the slope, what they did, they solved for y, which is what I was kind of debating in my mind. Do I want to solve for y first, or how did I want to play it? But they solved for y first, and then you can clearly see that the slope is 3 over 4. We did it a little bit different, but we got the same result. The y-intercept, we set x to 0. So if we set x to 0, the result is 3. You see it here. Okay. For the x-intercept, we set y to 0 and solve. Ultimately, you'll get here. Okay. Let me, and then the graph, you plot the x and y intercepts and connect them with the straight edge. I'm going to leave that be for now. I'm going to leave this showing, and let me let these other brothers in. I don't know if we have any females in here or not. Sometimes we do get like Spelman students and Clark students. Let me go like this. This student. This student. Ooh, that's a serious last name. This one. Cool beans. Okay, I think we got everybody. I'm gonna let them in. Okay, so what I'm doing here is I'm just wrapping up my presentation for section 1.2. Let me finish this presentation, and then I'll give you an update as far as, you know, presentations and things of that nature. I think he was in here already. Nope, he wasn't. Okay. So let's go like this. I'm gonna let him in. Okay. So yeah, let me wrap up this section. It's a few more slides remaining. I basically just continue my stream from the previous class with this one, and then I'll update you. So with this example, we're inferring heights from the femur. It says, and I'm going to mute the audio's fine for now. The height h of a human male is related to the length x of the femur by this formula, where all measurements are in centimeters. The femur of Wild Bill Longley was measured to be between 45 and 46 centimeters. I think, was he in here earlier? Oh, no, cancel. Nope, he wasn't. Cool. Okay. All these measurements are in centimeters. The femur of Wild Bill Longley was measured between 45 and 46 centimeters. Estimate the height of Wild Bill. Okay. So for something like this is basically a plug and chug. So say we consider, like if we do when x is 45 centimeters, right? All we're going to do, we have the first height, so I'm going to call it h sub 1, is going to be 2.6 times that 45. I don't know what I just wrote. Times the 45 plus 6.5. Not 6.5, plus 65, right? So all I did was plug in the 45, okay? I'm going to try something. I know it's going to speak in the other room because that's just how it's been behaving, but hey Siri, what's 2.6 times 45 plus 65? Oh, she got it. Did she hear it? She didn't hear the whole thing. Darn, I gotta disable that. Hey Siri, stop listening. I'm gonna have to set that up later. Because usually I like to use my phone for stuff like that because it's quick and I don't have to like break out a calculator. Give me a second. Okay, yeah, this student like came in and left, but that's okay. But yeah, I'm just gonna use my calculator. The Siri can do this kind of stuff, but I have it set up in the other room, so I'm just not gonna do it right now. I'm gonna just use my calculator. 2.6 times 45 plus 65. I got 182. Okay, I see the chat going. 182. I'll check it in just a moment. Let's do the second height. So if we say 2.6 times 46 plus 65. Okay. So I'm going to clear. I'm going to say 2.6 times 46 plus 65. We get 184.6. And these are the units here are centimeters, right? For the sake of time, I'm not going to convert these to feet and inches. I want to compare the numbers. We got the same results. We'll talk about conversions a little bit later, right? So that's converting from centimeters to inches, right? So then 70 inches is about 6 feet tall, right? Okay. I think we have like a couple more. Okay, let me pause for a moment because I know there was some activity in the chat. I'm just going to kind of check the chat real quick. Let's see. Yeah. So I take attendance. You get attendance by getting. Can you guys hear me? Okay. Uh-oh. Yeah, I think you can hear me. You get attendance. Let me check again. Can you guys hear me? New message. Had trouble getting. Yeah, okay. Okay, cool beans. Okay. So you get attendance. Right here. By getting into the Zoom. So because I take attendance as I let students into the Zoom. So once you get into my Zoom, you've got an attendance credit. We are doing asynchronous, which means you don't have to stay, but just hold tight. What I'm doing today, so I'm wrapping up section 1.2, but I'll give you an update on section 1.1 and everything else and kind of give you the idea behind everything. I'm just checking the chat. The labs. I think that this class, so you have to communicate with Dr. Lamar for the labs. She's kind of running the lab. She has those details. I don't know the details on that. Just email Dr. Lamar. She's much better at me responding to emails than I am. So to get into Pearson, you access it through Blackboard. So it should be linked directly into our Blackboard. You go to Blackboard, click on our course, then in folder number 4, it should say assignments. It's going to be there. And you're going to see a link at the top that's going to say all assignments. When you're making your way through Pearson, it's going to prompt you for an access code. You do have to purchase access. It runs about $105, right? But the idea is that we use the same book for this class, for College Algebra 2, and for Pre-Cal. So at least for 3 classes, as long as you're using the exact same book on Pearson, you don't have to purchase access again. So that access should give you, this should give you access for at least 3 of the classes that we teach here. These are good questions. Okay, I think the audio is fine, so we'll resolve that. Yeah, again, if you got into my Zoom, that means you got attendance. Let me say this about attendance as well. So the attendance grade that you see does not get factored into your overall grade. I just do attendance for record keeping. Like if an administrator shows up, hey, when was the last time you saw this student? Or did you have any kind of interaction with them? Hey, I was like, hey, they were here. They were in my Zoom on this day. I haven't seen them since, right? And attendance really only becomes an issue if you rack up about 3 or 4 unexcused absences. 3, I mean, we can kind of get by. But definitely if I see like a 4th unexcused absence, then I'm like, okay, wait a minute. What's going on with this person? and it can mess your money up. But yeah, but once you're into my Zoom, that means you've gotten attendance credit. Placement, I would talk to the math office for that. I'm just here talking about College Algebra 1. Again, I take attendance as I let you guys in. It's okay with the Zoom. And we talked about Pearson. Okay, cool beans. Okay, so let me wrap up this section. We're almost done. I got like 5 more slides, and then we'll do a recap. So let L1 and L2 be 2 distinct lines with slope 1 and slope 2, respectively. Then L1 is parallel to L2, or line 1 is parallel to line 2, if and only if slope 1 is equal to slope 2. Line 1 is perpendicular to line 2, if and only if slope 1 times slope 2 equals -1. Any 2 vertical lines are parallel, and any horizontal line is perpendicular to any vertical line. Okay? All right. Let me keep going. A little bit choppy, but we got through it. So in this example, it says, let L be 2x minus 3y plus 6. We're asked to find the equation of the line through the point 2, 8. And we want to find that's parallel to L, and line 2 is perpendicular to L. So let me get a screenshot of this. I'm going to give myself some space because the space that's showing right now is definitely not enough. So what I'm going to do, I want to copy. Did I do that right? Let me add a page. And I want to paste here. Cool. Okay, we're going to work with that. I'm going to let that be for now because people are still kind of coming in. Okay. And another thing I'd like to do, I want to do paper. I like to write on grid paper. Okay. So for this given line, find the equation of the line through this point parallel to this. So let me take some notes, right? So the given line is going to be this 2x minus 3y plus 6 equals 0. We wanted to go through the point 2, 8. And for part A, we want line 1 to be parallel. This is my abbreviation for parallel to L. And then for part B, we want line 2 to be perpendicular. This is my abbreviation for perpendicular to L. All these notes that you see me taking, I will make them available for you, and I'll make a link. I'm gonna rename one of the folders to box, and that'll be. I gotta set all that up. I'm waiting because I'm still missing something on Blackboard regarding all of that. There's only one thing, but it'll be done shortly, probably by the end of the week. But yeah, all the stuff that you see me writing from section 1.1, 1.2, and beyond, I'm going to make a link available for those. Okay. Okay. So we want this to be, so if we want it to be, so let's start with part A. If we want it to be parallel to L, that means it needs to have the same slope, right? So we need to find the slope of L. So here's L. We have this 2x minus 3y plus 6 equal to 0. I'm just going to solve for y. I'm going to add 3y on both sides. Again, there's more than one correct way to go about this. I'm just choosing something that works for me. Okay, on the left, if I bring down my equal sign, on the left, I'm left with 2x plus 6. On the right, I'm left with 3y. If I divide both sides by 3, so I'm going to say the entire right by 3, the entire left by 3. Because we're divided by a monomial, in other words, because we're divided by one term, I can actually distribute this division. I can distribute, right? So then we can rewrite it the following way. And we get this 2 over 3x, 6 over 3 equals y, and then I'm just going to switch the order because I don't like doing it that way. I'm just going to reverse it just for my own sake. Ultimately, we finish with y equals 2/3 x plus 2. Okay, so that means the slope of L is going to be 2. Right, so the slope that our slope, so that means the slope for line 1 needs to be 2. Okay, let me do this view, seamless, I'm gonna add a page. Okay, So if we wanted to be parallel, so then for part A, well, what's the working in A? So the slope of our line is going to be 2, and it needs to pass through the point 2, 8. Okay. So there's actually a couple of formulas that I can use here. I could use, let me see the time. I could use point slope. I'm actually going to use a slope-intercept formula. I have done an example or two on the point slope. This one I'm going to use the slope-intercept form. So slope-intercept, that's going to be your y equals mx plus b. Okay. So we have the slope, we have an x and a y. The only thing we don't have is b, so I'm going to plug all this in. So let's see, y is 8, the slope is 2, x is 2. Only thing we don't know is b. If we solve, if I subtract 4 from both sides, let me do like this. Four plus its opposite adds to 0. Ultimately, we get like b equals 4, right? So we got our y-intercept, we got our slope. So then the equation of that line, so the equation of line 1 is going to be y equals 2x plus 4. And let's rewrite it like this. We got this result. So this should be a line that's parallel to the first line passing through the given point. And we could verify like certain things. The slope is the same. Make sure that the point, when x is 2, y should be 8. And you can verify that. Let me see. H. Okay, I see. It's a little bit late, but better late than never. Let me see the time. It's okay. Okay, so that was part A. Part B, I think I could work on the right here. So for part B, we want line 2 to be perpendicular, right? So we know that the slope of L, we know that slope was 2, right? So if we want the second one to be perpendicular, then slope 2 times the slope of L needs to equal -1. So that means slope 2 times 2 should equal -1. So that means slope 2 should equal -1/2. So that's the slope of our second line. So we have a slope, and again, we want it to pass through the point 2, 8. Okay. And just for contrast, since I did the last one in slope-intercept, I'm going to use the point slope for this one. So point slope formula, that's going to be y minus y1 equals m times x minus x1. Okay. And again, this is my x1, y1, and we got the slope up there. So if I plug these in, we're going to have y minus 8 equals a -1/2 times x minus 2. So if I notice that students are coming in like after the 15-minute mark consistently, then I'm gonna stop giving credit for showing up after the 15-minute mark. Right now I'm giving everybody credit just because we're just getting started, so I'm not gonna make a big deal about it. Let me go ahead and solve for y here. Let me think how I want to do this. I'm gonna get rid of that. Let me think about it. Yeah, okay. So let me start by, I'm going to distribute this 1/2. We have fractions, but we just got to face them. We have this y minus 8. We're going to have a -1/2 x plus 1. And then we add 8 on both sides. Okay. And then we get y equals -1/2 x plus 9. Okay, and this is the equation of line 2, a line that's perpendicular to the original line and passes through the given point. Now, we could verify this stuff by like graphing it in a calculator or some kind of like digital graphing software. If you want to use some digital graphing software, you can use like this website called geogebra.com. That's a good site for free digital graphing. I think another one is called like Desmos. I think that's what it's called. I think that's what students use. I'm going to put a question mark for that one just because I'm not sure. But I've used GeoGebra. It's good for like digital graphs. And I have another one. I have like a virtual graphing calculator, but I'll bring it up later. Let me just compare this. Single page. Let me just compare this to my type notes. Okay. So we got these results: 2x plus 4, negative 1/2 x plus 9. Okay. Did we get a slope wrong? We got 2. Did I miss something? I may have missed something. 2/3. Oh, shoot. I did miss something. Oh, shoot. I don't know why I wrote 2. You know why? Because I was writing too small. So the slope is, I see, I found the error. Let me go ahead and fix it. I just gotta suck it up and fix it, right? So the slope of the line is not 2, it's 2/3. 2/3, right? So writing too small, I missed it. So let me go back and fix stuff. So the slope 2 times the slope of our line needs to equal -1. So right here it should be a 2/3. So you multiply by the reciprocal, that should be 3/2. So let me cross this out. This is supposed to be a -3/2. Okay. So that's -3/2. So right here, this is supposed to be 2/3. This mx plus b, this is supposed to be 2/3 here. Okay, so I think from there, I'm gonna redo it. I'm just gonna redo it. Let's get rid of this, delete. Okay, so now we got the proper slope and we want to pass through that point. So then we're going to say y equals 2/3 x. So 2/3 times 2 plus b, and I think our y is 8. Okay. So then ultimately, b is going to be equal to 8 minus 4/3. 8 times 3 is 24, so 20/3. You can use a calculator. So then y equals 2/3 x plus 20/3. Okay. So again, that's why it's important to check. I was kind of going a little bit fast. It's a little bit of a challenge, streaming, taking attendance, you know, distractions and stuff of that nature, but it's not a big deal. So we resolved that one. Let's go back and fix this other one. Okay, I think that's okay. Right here. I think that's where I need to go back to. Okay. So let me get rid of this stuff here. I'm going to get rid of this. Delete. Okay. So we know our slope needs to be a -3/2. And I think it still passes through the point 2, 8, right? So let's see. So our y is 8. The slope is a -3/2. X is 2. Again, the only thing we don't know is b. So then b is going to be equal to, what is that, 6/2, which is 3. Add 3 on both sides. So I think we get 11. So then we get y equals a -3/2x plus 11. Okay, again, we should check. I'm just using my notes because I have them available. But we should check that, like, we can see that the slopes are negative reciprocal, but we need to make sure that the original point works in these, right? Okay, so I think we caught the mistake. Let's go with these. We got 2/3 x plus 20/3. Okay. Oh, and they put it in standard form. Okay, I mean, we could do that. Okay, let me go ahead and put these in standard form. So then to put them in standard form, for instance, for the first one, we're going to get rid of the fractions. So I'm going to multiply the left by 3 and the right by 3. Okay. When you distribute that 3 on the right, it cancels the 3's on the bottom. So then on the left, we have 3y equals 2x plus 20, okay? We usually write it with the x term being positive, so I'm going to subtract the 3y and then subtract the 20. We'll get 2x minus 3y equals negative 20. That should match what they have, so you can see where it came from. And then let me do the same thing on the other. And not to say that our first answer was wrong, it's just a different form. I'm going to multiply the left and the right by 2 to cancel out my fractions. Okay, I'm going to distribute a 2 on the right-hand side. So then on the left, we get 2y. On the right, we're going to get negative 3x plus 22. Again, we usually like to write, when we write it in standard form, I usually like the x to be positive. So I'm going to add the 3x on both sides. We get 3x plus 2y equals 22. Okay, so now these should match what they have. Style like this. Okay, so we got 2x minus 3y equals negative 20. And you see it, 2x minus 3. Yeah, if we bring the 20 over, yeah, you got to set it to 0. And then we see the 3x plus 2y minus 22 equals 0. Just set it to 0. Oh, that was it. Okay. So that was the more challenging part because that was the end of the section, right? That was the last example. So what I was doing with these presentations, it was a little bit choppy because of like the timing of everything, but it's okay. So I did notice that, you know, section 1.1 in my previous recordings, the video didn't work. Let me make sure. It's kind of too late now, but I think it's fine. So I was like, well, let me go ahead and redo section 1.1. And then I was like, well, let me just go ahead and redo them all. So I'm making fresh like versions of the sections. So it should be in like one playlist. You'll see section 1.1 where I redid it. And this was the conclusion of section 1.2. You know, and I'm going to try to get a little bit ahead in the lecture presentations. And then, so, you know, once we're a little bit ahead, then we'll use the rest of the class to kind of like work through homework. So like today is what it is. I think we still got a good amount of time, like 20 odd minutes, give or take. So, you know, we can use that for like homework practice or anything of that nature. I can't really think of anything else. I think I'm just going to make myself available for the rest of the class. I'm just going to be here like on the Zoom, but I'm kind of like, I can't talk anymore. So I'm just going to be available. So like if you have questions or if you want to work through your homework, we can, or anything that's math related, we can work through it. Otherwise, you know, that's it. Let me, yeah, like I said, I'm making a playlist with these updated things. I'm also going to be updating Blackboard to include like a link for the PDFs of anything that you see me writing. I'm going to make that available. It's just, I need IT to kind of update my Blackboard before I can do that for one other thing. But yeah, like honestly, if there aren't any questions, I'm not going to keep you. I'm just going to be available here during the Zoom session, but I'm not going to keep talking. Okay, so the assignments. Yeah, let me stop the stream and I'll show you how to access the assignments.